A few years ago, astrophysicist Franco Vazza met his old friend Alberto Feletti, now a practicing neurosurgeon, at a bar. As the two men caught up over drinks, their conversation drifted naturally between their respective worlds. Vazza's research into the large-scale structure of the universe and Feletti's intimate familiarity with the human brain. Somewhere in the middle of that exchange, between the half-empty glasses and the ambient noise of the room, an idea quietly took root. Why not compare the two? Why not hold the architecture of the cosmos up against the architecture of the mind and see what, if anything, reflected back? Vazza, based at the University of Bologna in Italy, took the challenge seriously. Using sophisticated statistical analysis, he began comparing the brain's neuronal network, the vast, interconnected web of cells that gives rise to thought, feeling, and awareness, to the cosmic web, the enormous and intricate pattern of matter that stretches across the observable universe. He examined the number of nodes in each network. He analyzed the connectivity between them, the clustering, the distribution of density, the way each system organized itself across its respective scale. What he found was not what most people would have expected. The similarity, Vazza said, is amazing. The two structures differ in scale by roughly 27 orders of magnitude. The human brain fits inside your skull. The cosmic web spans billions of light years in every direction. And yet the patterns they form, the way nodes cluster, the way filaments branch and extend and curve back upon themselves, are strikingly, almost eerily, similar. For some scientists, that resemblance is simply too consistent to ignore. It has led a growing number of thinkers, researchers, and philosophers to entertain a proposition so sweeping in its implications that it borders on the metaphysical that the universe itself may think. That it may, in some fundamental and deeply alien sense, possess a form of consciousness. In a sense, referring to the human brain as a 3-pound universe might be closer to the truth than we ever dared to realize. When scientists examine the two most structurally complex and intellectually captivating phenomena known to science, the human brain's neuronal network and the cosmic web of galaxies, the resemblance is genuinely uncanny. It goes beyond surface-level visual similarity. It penetrates into the statistical, the mathematical, the structural, the organizational, and it raises questions that cut to the very heart of what we think we understand about the nature of reality. How would you react to the idea that the very chair you are sitting on right now is composed of tiny particles that harbor some rudimentary form of existence? How would you respond to the suggestion that the potted plant sitting near your window, the 4 walls enclosing the room you occupy, the air you are breathing in this very moment, that all of these things possess some interior dimension, some faint and alien flicker of awareness? What if the world surrounding you was not an inert, inanimate stage upon which you, the sole bearer of a soul, played the lead role, but was instead, in some profound and irreducible sense, fully awake? Awake in the way that you are awake, or awake in some manner so different that we barely have the vocabulary to describe it? This idea has a name. It is called panpsychism, and it is the theory that everything, every particle, every field, every configuration of matter, from the subatomic to the cosmological, has a mind, or at the very minimum, a mind-like quality. Panpsychism does not necessarily mean that rocks are plotting. It does not mean that the ocean is strategizing, or that a distant nebula is composing poetry. What it means, at its most stripped down and philosophically precise, is that the capacity for experience, the raw, irreducible fact of there being something, it is like to be something, is not an accident of biological evolution confined to a thin layer of neurons in a handful of species on a single unremarkable planet. It means, instead, that experience is woven into the fabric of reality itself, that it is not something the universe produced by accident, but something the universe has always, in some sense, been. The concept of panpsychism has been circulating through human intellectual history for a very long time. Italian philosopher Francesco Patrizzi coined the specific term in the late 16th century, but the underlying intuition is far older. In ancient Greece, the astronomer, mathematician, and pre-Socratic philosopher Thales, widely regarded as one of the founding figures of Western philosophy, asserted that everything is full of gods, a claim that scholars have long interpreted as suggesting a kind of pervasive vitality or awareness, threading through all matter. Plato, one of the most thoroughly studied and influential philosophers in all of human history, went further still, declaring that the world is a living being endowed with intelligence. These were not fringe positions in their time. They were serious philosophical propositions, advanced by serious thinkers grappling with the deepest questions available to the human mind. For centuries, panpsychism was gradually displaced from the center of intellectual discourse as the mechanistic worldview took hold, the Newtonian picture of a universe operating like a vast, impersonal clockwork, indifferent and inert, governed entirely by deterministic physical laws. Consciousness became an outlier in that picture, an embarrassing anomaly, something that materialist philosophy struggled to explain and often quietly swept beneath the rug of future inquiry. The standard assumption was that if you just got the physics right, and then the chemistry, and then the biology, consciousness would eventually emerge from the complexity, the way wetness emerges from water molecules, even though no individual water molecule is wet. But something strange has happened in recent decades. That assumption, comfortable, tidy, apparently scientific, has started to crack. The fact that empirical science cannot explain how matter creates conscious experience has renewed interest in panpsychism with a seriousness and rigor that would have been difficult to predict even 30 years ago. The so-called hard problem of consciousness, a phrase coined by philosopher David Chalmers in the 1990s, captures the difficulty precisely. It is not especially hard, at least in principle, to imagine how a sufficiently complex information processing system might produce intelligent behavior, might respond adaptively to its environment, might exhibit all the functional hallmarks of a mind. What is genuinely, perhaps impossibly hard, is explaining why any of that processing should be accompanied by subjective experience, why there should be something it is like to be a thinking system at all, rather than simply the processing occurring in the dark, without any inner light of awareness. Science can describe the neural correlates of consciousness in exquisite detail. It cannot explain why those correlates give rise to experience rather than simply to more processing. That explanatory gap, vast, stubbornly resistant to closure, has sent a growing number of scientists and philosophers back toward ideas that the mainstream had largely abandoned. And panpsychism, with its suggestion that consciousness is not something the universe produces in special circumstances, but something the universe fundamentally is, has emerged as one of the most intellectually serious candidates for filling that gap. Developments in neuroscience, psychology, and quantum physics have all contributed to this renewed interest. In neuroscience, the discovery of quantum-level processes within biological cells, including within neurons, has complicated the picture of the brain as a purely classical information processor. In psychology, the persistent failure of purely functionalist models to capture the phenomenal quality of experience, the redness of red, the painfulness of pain, the particular texture of any given moment of consciousness has kept the hard problem stubbornly alive. And in quantum physics, the measurement problem, the strange role that observation seems to play in determining the states of physical systems, has raised questions about the relationship between mind and matter that have never been fully resolved. For some scientists and philosophers, panpsychism offers what they describe as an elegant solution to these interlocking problems. It suggests that consciousness is not a late arrival, a byproduct of sufficiently complex biological machinery, but rather a fundamental feature of reality present in some form at the most basic levels of the physical world. In this view, human consciousness does not emerge from matter in the way that wetness emerges from water molecules. It emerges from matter in the way that a symphony emerges from individual musical notes, not because any single note contains the whole symphony, but because the symphony is a particular kind of relationship between notes and relationships between things that already have some interior quality can give rise to a richer and more complex interior quality than any individual element possesses. This idea gives rise to a compelling picture of how consciousness scales. Through a series of physical and chemical processes that we understand with increasing precision, subatomic particles come together to form atoms. Atoms combine to form molecules. Molecules organize into cells, cells into organs, organs into entire organisms. Each step in this progression represents a qualitative increase in the complexity of the network, the number of connections, the richness of the relationships, the depth of the integration. If the basic ingredients already carry some faint, primitive form of experience, then what we experience as human consciousness may be the extraordinary elaboration of that primitive quality across billions of interconnected units, in the same way that an enormously complex network of simple logical switches gives rise to the staggering computational power of a modern computer. These structures represent increasingly complex layers of connections within quantum fields. In contemporary physics, this is not a metaphor or a vague gesture toward profundity. It is a precise technical claim. Quantum field theory, the most successful and rigorously tested physical framework ever developed, describes all particles and all forces as excitations of underlying quantum fields that permeate all of space and time. Everything that exists, including the atoms that make up your brain, the photons that carry light to your eyes, the air you breathe, the ground beneath your feet, all of it is, at its most fundamental level, patterns and relationships within these underlying quantum fields. The distinction between matter and field, between particle and wave, between substance and process, dissolves at this level. What we recognize as physical matter is not a collection of tiny, solid things bumping against each other in empty space. It is the result of intricate, dynamic patterns in fields that are, in a very real sense, everywhere and everything. This framing carries an extraordinary implication. If consciousness is in some sense associated with the nature of these quantum fields, if it is not something that emerges from the fields under special conditions, but something that characterizes the fields themselves, then consciousness is not a local phenomenon confined to biological brains. It is a feature of the fabric of reality. It is everywhere the fields are. Which is everywhere? Researcher Henry Stapp put forward a version of this argument in 1999, asserting that consciousness might be the overriding force behind brain function, not merely a product of the brain, but the context within which the brain operates. This represents a significant departure from the traditional view, in which the brain produces consciousness the way a generator produces electricity. In Stapp's framework, the relationship is inverted. The brain does not produce consciousness, but rather participates in it. Consciousness is the medium. The brain is an organ finely tuned to navigate and utilize it. Stapp's views suggest that if the brain is an integral part of a quantum network or field through which consciousness manifests, then the brain exists within consciousness rather than consciousness existing solely within the brain. It is a subtle distinction, but its implications are staggering. If the brain exists within consciousness rather than generating it, then the question of where consciousness comes from dissolves because consciousness was always already there. The question becomes not how consciousness arises from matter, but how particular patterns of matter come to be in certain configurations and under certain conditions, especially sensitive and elaborate windows into the field of consciousness that underlies everything. A related idea, sometimes called cosmopsychism, takes this logic one step further and argues that the universe as a whole is the fundamental seat of consciousness, that the cosmos is not a collection of things, some of which happen to be conscious, but a single, vast conscious entity, with individual minds constituting something like local nodes or expressions within a larger whole. It is a breathtaking idea, and one that is not without philosophical difficulties. Even Vazza himself, whose comparison of the brain and the cosmic web helped spark much of the recent public interest in these questions, is skeptical of it. We cannot even define consciousness, he says, so it seems strange to attribute it to the universe as a whole. His study was aimed at understanding how complex networks organize themselves, not at suggesting that the universe thinks. And Vazza's caution reflects a genuinely important point. Just because two things look alike does not mean they function the same. A living brain and a dead brain, after all, have essentially the same physical structure, and yet one is the seat of experience and the other is not. The structural similarity between the cosmic web and the neuronal network may be remarkable and may be pointing towards something genuinely deep about the physics of complex self-organizing systems. But structural similarity is not the same as functional equivalence, and visual analogy is not the same as empirical demonstration. The universe is, furthermore, almost unimaginably vast, so vast that any signal traveling between different regions of it would take not milliseconds, but billions of years to arrive. If there is something like thought happening at a cosmic scale, it would operate at a pace so glacially slow as to be almost unrecognizable as thought from any perspective accessible to human minds. Philosopher Philip Goff offers a more measured version of the cosmopsychist position in his book Why? The Purpose of the Universe. Goff argues that particles should be understood as manifestations of quantum fields, and that these fields, being the most fundamental constituents of reality, could be the basic units of consciousness. He is careful to clarify that this does not mean the universe thinks reflectively in the way that a human mind deliberates and reasons. What he wonders is whether this fundamental, field-level mind could exert some influence on the evolution of the universe over time, not through deliberate reasoning, but through something more primitive and pervasive, a kind of cosmic attunement or inclination. Whether any of this is true remains, for now, beyond the reach of scientific proof. We do not yet have the conceptual tools, let alone the empirical methods, to test these ideas with the rigor that science demands. What we have are suggestive analogies, philosophical arguments, and a growing sense among a significant number of serious thinkers that the materialist consensus of the 20th century was not the final word on the nature of reality, but merely a productive and necessary chapter in a much longer story that is still being written. Perhaps the rise of panpsychism reflects changes in the cultural and intellectual atmosphere as much as it reflects changes in the state of scientific knowledge. The metaphors we use to understand the universe have always been shaped by the technology and the concerns of their era. During the Industrial Revolution, the universe was imagined as a vast and intricate machine, gears turning, pistons firing, everything operating according to fixed mechanical laws. The clockwork universe was a natural metaphor for a civilization that had recently discovered the power of mechanism. During the digital revolution of the late 20th century, the brain came to be compared to a computer input, processing, output, memory, algorithms. The computational metaphor was a natural expression of a civilization increasingly organized around information technology. Now, in the early decades of the 21st century, we find ourselves in an era defined by artificial intelligence, machine learning, and a rapidly deepening understanding of networked systems and emergent complexity. In this context, a new metaphor is taking shape. The universe as a vast neural network, not metaphorically, but structurally, organizationally, perhaps even functionally. With growing ecological awareness and a deepening appreciation for the interconnectedness of all living systems, it is perhaps not surprising that our civilization is turning toward more organic, more integrated, more relational ways of thinking about the cosmos. And the underlying science, however tentative its philosophical implications may be, is genuinely striking. The human brain contains approximately 100 billion neurons. These neurons form roughly 100 trillion synaptic connections. They organize themselves into networks of nodes, filaments, and clusters networks through which the electrochemical signals that underlie thought, feeling, memory, and consciousness ceaselessly flow. But here is a detail that often surprises people. Neurons make up less than 25% of the mass of your brain. The remaining 75% is water, along with supporting cells and structural material. The computational substrate of the mind is, in terms of sheer bulk, a minority constituent of the organ that houses it. Now, consider the observable universe. Scientists estimate that it contains approximately 100 billion galaxies. These galaxies do not float freely and uniformly distributed through empty space. They are organized, structured, pulled and pushed by the competing forces of gravity and the accelerating expansion of the cosmos into an intricate architecture known as the cosmic web. Vast filaments of ordinary matter and dark matter stretch across incomprehensible distances, weaving together into a structure that, when imaged through modern telescopes and rendered in computer simulations, bears a striking resemblance to the network of neurons imaged through modern microscopes and rendered in computer models of the brain. Galaxies cluster at the intersections of the filaments, just as neurons cluster at the nodes of the neural network. Between the filaments lie enormous voids, regions of near emptiness that correspond structurally to the spaces between neuronal clusters in the brain. And here is the statistic that strikes many people as almost uncanny. Scientists estimate that only about 25% of the matter in the universe is visible ordinary matter, the kind made of atoms, the kind we can detect and measure and interact with directly. The remaining 75% is dark matter, a mysterious substance that exerts gravitational influence but does not emit or absorb light, and whose ultimate nature remains one of the deepest unsolved problems in all of physics. 25% active, structured, visible matter. 75% something else entirely. The brain and the cosmos, separated by 27 orders of magnitude in scale, share this peculiar ratio. Vazza and Feletti were aware that these numerical and visual similarities, however striking, were not sufficient to establish any deep connection between the two systems. Superficial resemblance is easy to find and easy to overinterpret. What they wanted was a rigorous, quantitative comparison, one that used the same analytical tools applied consistently to both systems and assessed whether the similarity held up under mathematical scrutiny. They used power spectrum analysis, a technique originally developed in astrophysics to study the large-scale distribution of galaxies. Power spectrum analysis allows you to characterize the way a complex pattern distributes its structure across different spatial scales, how much of the variation in the pattern occurs at large scales versus small scales, and how those variations relate to each other mathematically. By applying this technique to both a simulation of the large-scale distribution of galaxies and to sections of the brain's cerebellum and cerebral cortex imaged at microscopic resolution, Vazza and Feletti were able to make a genuinely quantitative comparison. Their findings were remarkable. The distribution of fluctuations within the cerebellar neuronal network across scales ranging from 1 micrometer to 1/10 of a millimeter followed the same mathematical progression as the distribution of matter in the cosmic web across scales ranging from 5 million to 500 million light-years. The slopes of the power spectra, the mathematical signatures of how structure is organized across scale in each system, were nearly identical. Not similar in a vague impressionistic sense, but similar in a mathematically precise and statistically significant sense. The two systems also turned out to be comparable in terms of their information capacity. The human brain, according to some estimates, can store up to 2.5 petabytes of information, roughly equivalent to about 3 million hours of high-definition video. The observable universe, as a network of connected nodes and filaments, appears to have a comparable information capacity when analyzed using similar network-theoretic tools. Again, this does not prove that the universe is conscious or that it processes information in the way a brain does, but it suggests that at the level of organizational complexity and information storage capacity, the two systems operate in surprisingly similar territory. What does it mean that two systems, so radically different in scale, composition, origin, and physical mechanism, should nevertheless organize themselves according to such similar mathematical principles? There are several possible answers to that question, and they are not mutually exclusive. One answer, favored by many physicists and mathematicians, is that these similarities reflect the operation of universal mathematical principles that govern the behavior of complex, self-organizing networks regardless of the specific physical substrate. Networks that form through processes of accretion, connection, and feedback, whether those processes involve galaxies clustering under gravity or neurons forming synaptic connections in response to experience, tend to develop similar structural properties because those properties are in some sense optimal solutions to the organizational challenges that complex networks face. On this view, the similarity between the brain and the cosmic web is not mysterious or metaphysically loaded. It is simply an expression of deep mathematical regularities that operate across many different physical systems. Another answer, more speculative, but not obviously wrong, is that the similarity reflects something more profound about the nature of complexity itself. Perhaps the kind of structure that can process information, or support something like experience, or give rise to what we recognize as mind, is not arbitrary. Perhaps it has a preferred form, a characteristic architecture that emerges whenever the relevant conditions are met, regardless of scale or substrate. If that is true, then the fact that the cosmos organizes itself into a structure resembling a neural network is not a coincidence. It is the universe doing what minds do, at a scale that dwarfs anything we can easily contemplate. A third answer goes further still. Perhaps the similarity is not incidental or mathematical, but causal. Perhaps the universe is organized the way it is precisely because consciousness, or something like it, is a fundamental feature of the quantum fields that constitute all of physical reality. On this reading, the brain and the cosmic web look alike, not merely because they are both complex networks, but because they are both expressions of the same underlying reality, organized by the same underlying principles at different scales. We are not yet in a position to choose definitively between these answers. The science is genuinely uncertain, and the philosophical questions are genuinely hard. But the questions themselves, the fact that we are asking them, the fact that the data makes them unavoidable, represent a significant shift in the intellectual landscape of our time. To understand why these questions have acquired such urgency, it helps to understand what we actually mean when we talk about consciousness, what we mean when we talk about quantum mechanics, and how those two domains of inquiry have begun, slowly and tentatively, to intersect. Consciousness, at its most basic, refers to the fact of subjective experience, the fact that there is something it is like to be a particular entity at a particular moment. When you look at the blue sky, there is an experience of blueness. When you feel pain, there is an experience of painfulness. When you listen to music, there is an experience of sound organized in time, of rhythm and melody and harmony, of something that moves you in ways that cannot be fully captured by any description of the physical vibrations that produced it. These experiences, their qualitative character, their irreducible first-person dimension, constitute what philosophers call phenomenal consciousness. or qualia. The mystery of consciousness is not primarily a mystery about behavior or function. We can, in principle, build systems that respond to blue light differently from red light without those systems having any experience of color. We can, in principle, build systems that withdraw from damaging stimuli and emit signals associated with tissue damage without those systems having any experience of pain. The behavior can, in principle, be explained without invoking experience at all. The mystery is why, in certain physical systems paradigmatically, in biological brains, the relevant processing is accompanied by experience. Why is there something it is like to be a brain, while there is presumably nothing it is like to be a thermostat? This is the hard problem of consciousness, and it is genuinely hard. It is not merely a matter of needing more data or more computational power. It is a conceptual problem, a puzzle about how any physical description of the world can account for the subjective, experiential dimension of conscious life. Physical descriptions describe the world from the outside. They describe the structure of systems, the dynamics of processes, the patterns of information flow. But consciousness is a fact about the inside, about how things are from a particular point of view. No accumulation of outside descriptions, however detailed and precise, seems to logically entail anything about inside facts. You can describe every neuron in a person's brain, every synapse, every electrochemical cascade, and the description will be complete as a physical description, and yet it will leave entirely open the question of whether there is anything it is like to be that brain. The inside fact, the fact of experience, seems to be over and above the outside facts, no matter how complete the outside picture is. This is why some philosophers argue that consciousness cannot be explained in purely physical terms, and why panpsychism, with its suggestion that experience is fundamental and ubiquitous rather than derived and local, has attracted renewed attention. If experience is a fundamental feature of reality, if it is not something produced by certain physical processes, but something that characterizes the most basic constituents of the physical world, then the hard problem dissolves. Not because it has been solved, but because the premise that generates it, the premise that experience emerges from matter, turns out to be false. Matter, on the panpsychist view, is already experiential all the way down. Human consciousness is not a miracle or an anomaly or a product of improbable evolutionary accident. It is what happens when the experiential nature of fundamental reality organizes itself into the extraordinarily complex and integrated structure of a functioning human nervous system. This is a genuinely attractive idea. Intellectually, it has the virtue of not requiring a discontinuity, a sudden emergence of something entirely new at some point in the history of the cosmos. It treats consciousness as continuous with the physical world rather than as an intrusion into it. It suggests that the universe was not, for its first 10 billion years or so, a place of pure darkness and meaninglessness that then, in the blink of a geological eye, began producing pockets of awareness when life evolved on certain planets. It suggests instead that the universe was, from the beginning, lit from within, that awareness was present in the first instant, however primitive and attenuated, and has been elaborating and deepening ever since. But panpsychism faces serious objections, and they deserve to be confronted honestly. The most significant is the combination problem. If fundamental particles have some form of experience, how do those micro-experiences combine to produce the unified, integrated experience of a conscious human being? A single neuron presumably has, on the panpsychist view, some infinitesimally primitive form of experience. 100 billion neurons, firing in coordinated patterns, presumably have some much richer and more complex form of experience. But what is the mechanism by which the micro-experiences of individual neurons combine to produce the unified macro-experience of a person? This combination problem is, in some respects, just as hard as the original hard problem. It does not obviously go away simply by pushing the question down to a lower level of organization. Defenders of panpsychism have proposed various solutions to the combination problem, ranging from integrated information theory, which attempts to quantify the degree of consciousness in any system based on the integrated complexity of its information processing, to views that locate the key combinatorial step in quantum mechanical phenomena at the neuronal level, potentially involving quantum coherence in biological microtubules, as proposed by physicist Roger Penrose and anesthesiologist Stuart Hameroff in their controversial orchestrated objective reduction, or ORCH-OR, framework. None of these solutions is yet fully satisfying to all parties in the debate, but the debate itself is live, serious, and ongoing in a way that would have seemed unlikely even a generation ago. What has changed? Why now? Part of the answer is simply the accumulation of data and the development of new theoretical frameworks. The discovery of quantum processes in biological systems, the development of network science as a rigorous mathematical discipline, the construction of instruments capable of imaging both the neural architecture of the brain and the large-scale structure of the cosmos, with unprecedented resolution, all of these have provided new empirical footholds for questions that were previously purely philosophical. The comparison between the brain and the cosmic web is only the most dramatic example of a broader pattern in which the tools of one field are found to illuminate unexpected connections with another. But part of the answer may also be cultural and philosophical. The 20th century's confidence in materialism, in the ability of physics and chemistry and biology to give a complete account of reality, including the reality of mind, has been gradually eroded, not by mysticism or superstition, but by the persistent failure of that project to deliver on its most fundamental promise. The hard problem of consciousness remains hard. The measurement problem of quantum mechanics remains unresolved. The nature of dark matter and dark energy, which together constitute approximately 95% of the energy content of the universe, remains deeply mysterious. The standard model of particle physics, successful as it is, leaves unanswered questions about why the fundamental constants of nature have the particular values they have, values that seem, in many cases, to be precisely calibrated for the existence of a universe capable of harboring complex structures and, eventually, life. In the face of these persistent mysteries, the confident materialism of the 20th century looks less like the final answer and more like one chapter in a story that has many more chapters yet to come. And in the space opened up by that uncertainty, older and stranger ideas about the nature of mind and matter, about the relationship between consciousness and the physical world, about the possibility that the universe is not merely a stage upon which consciousness performs, but a participant in the drama, are finding new purchase. The physicist John Wheeler, who coined the term black hole and was one of the most creative and influential theoretical physicists of the 20th century, spent the final decades of his career arguing that the universe is, at its most fundamental level, made not of matter, but of information. He called this view it from bit the idea that every physical quantity, every particle, every field, every force derives its existence from answers to yes or no questions, from binary choices, from bits of information. In Wheeler's universe, the physical world is not the foundation from which information and meaning emerge. Information and meaning are the foundation from which the physical world emerges. Wheeler even went so far as to describe the universe as participatory, as a system in which conscious observers are not passive spectators watching a pre-existing show, but active participants whose observations, in a quantum mechanical sense, help bring the physical world into being. The boundary between the observer and the observed on this view is not a clean, sharp line. It is a fuzzy, interactive, mutually constitutive relationship. The universe makes minds, and minds, in observing the universe, in some sense, make the universe. This is a deeply counterintuitive idea. It runs against the grain of common sense, which tells us that the world was there before we were, that it will be there after we are gone, and that our observations of it are simply our way of gathering information about something that exists independently of us. But common sense is notoriously unreliable when applied to the quantum realm, and Wheeler's argument is grounded not in mysticism, but in a careful and rigorous engagement with the mathematics and the empirical findings of quantum mechanics. To understand why Wheeler reached these extraordinary conclusions, it is necessary to grapple with the central mystery of quantum mechanics, a mystery that has haunted physics since the theory was first formulated in the 1920s, and that remains, despite the theory's extraordinary predictive success, fundamentally unresolved. Quantum mechanics describes the behavior of matter and energy at the smallest scales. It is, by any measure, the most successful scientific theory ever formulated. Its predictions have been confirmed by experiments of extraordinary precision, and the technologies that depend on it, from transistors to lasers to MRI machines, are the foundation of modern civilization. And yet, at its heart, lies a paradox that no one has yet fully resolved, the paradox of the wave function. In quantum mechanics, every physical system is described by a mathematical object called the wave function. The wave function does not describe a definite state, a particle at a specific location with a specific velocity, the way a classical description would. Instead, it describes a superposition of all the possible states the system could be in, each weighted by a probability amplitude. When no one is looking, when no measurement is being made, a quantum system evolves smoothly and deterministically according to the Schrödinger equation, its wave function spreading and interfering with itself like a wave on the surface of a pond. But when a measurement is made, when an observer interacts with the system and records an outcome, something strange happens. The wave function, which had been spread across a range of possible states, suddenly and discontinuously collapses to a single definite state, the one that was observed. The probabilities snap into certainty. The range of possibilities contracts to a single actuality. This is the measurement problem. And the reason it is a problem is that quantum mechanics itself does not tell us in any satisfying way what counts as a measurement, what triggers the collapse, or why observation should have this radical effect on physical reality. The mathematics describes what happens beautifully. It does not explain why it happens. And the various interpretations that physicists and philosophers have proposed over the decades to explain the collapse, the Copenhagen interpretation, the many worlds interpretation, the pilot wave theory, the relational interpretation, quantum Bayesianism, and many others differ not merely in their technical details, but in their most fundamental claims about the nature of reality. Some of these interpretations assign a special role to consciousness. The earliest and most influential attempt to make sense of quantum mechanics, associated with Niels Bohr and Werner Heisenberg, and known as the Copenhagen interpretation, drew a sharp distinction between the quantum system being measured and the classical measuring apparatus, doing the measuring and, by extension, the conscious observer reading the result. The collapse of the wave function, in this picture, occurs at the boundary between the quantum and the classical, at the moment when the measurement result enters the awareness of a conscious observer. Consciousness, in this reading, is not merely a passive recorder of facts about a pre-existing physical world. It is the agent whose act of observation precipitates the transition from quantum possibility to classical actuality. This was a startling claim when it was first made, and it remains startling today. Most physicists, if pressed, will say that they do not believe consciousness literally causes wave function collapse, that the collapse happens due to some physical process, perhaps decoherence, perhaps some yet-to-be-discovered objective physical mechanism, and that the apparent role of the observer is simply a feature of the particular way we happen to set up and describe our experiments, not a fundamental feature of nature. But this reassuring dismissal has never been fully satisfying, because the mathematics of quantum mechanics does not obviously support it. The theory's formalism assigns a special role to measurement, to the interaction between a system and an observer, that does not obviously reduce to a purely physical process without introducing additional assumptions that are not themselves derived from the theory. John Wheeler took the role of the observer more seriously than almost anyone else in mainstream physics. His most dramatic illustration of the participatory universe was a thought experiment called the delayed choice experiment, later realized as an actual laboratory experiment with results that confirmed his predictions. In Wheeler's delayed choice setup, a photon is fired at a beam splitter that gives it a 50-50 probability of taking either of two paths to a detector. If you set up the experiment to measure which path the photon took, you get a definite answer. It went one way or the other. If you set up the experiment to measure the interference pattern, a signature of the photon having travelled both paths simultaneously, as a wave, you get an interference pattern. So far, this is just standard quantum mechanics. The twist comes when you delay the choice of which kind of measurement to make until after the photon has already passed the beam splitter. In classical physics, the photon's path is determined the moment it encounters the beam splitter. Either it went one way or it went the other way, and that fact is fixed from that moment on, regardless of what anyone later decides to measure. But the results of the delayed choice experiment, both in Wheeler's thought experiment and in its subsequent laboratory realizations, show that the photon's behavior appears to depend on the choice of measurement made after the fact. If you choose to measure which path, the photon behaves as if it took one definite path. If you choose to measure the interference pattern, the photon behaves as if it took both paths simultaneously. The choice made after the photon passed, the beam splitter, appears to retroactively influence what the photon did at the beam splitter. Wheeler drew from this a sweeping and radical conclusion. The universe, he said, does not exist as a collection of definite things with definite properties that are simply waiting to be observed. It exists at the quantum level as a superposition of possibilities, a vast, shimmering field of potential actualities, and it is the act of observation that calls specific actualities into being, not just in the present, but in a sense that reaches backward into the past. The universe, Wheeler argued, is in a very real sense brought into being by the participation of those who observe it. And because the universe is old, and we are recent, the implications of this are cosmological in scale. Every observation we make today is, in a sense, participating in the creation of a universe that began nearly 14 billion years ago. This is not mysticism. Wheeler was one of the most rigorous and mathematically sophisticated physicists of his generation. He was deeply committed to empirical science and deeply skeptical of vague or untestable metaphysical speculation. When he said the universe is participatory, he meant it as a precise claim derived from a careful reading of the implications of quantum mechanics, implications that he believed the physics community had been too reluctant to face squarely. The participatory universe is connected to a broader framework that Wheeler developed over the course of his career, in which information, not matter, not energy, not space, is the most fundamental constituent of reality. It from bit, he called it, as we touched on earlier. Every it, every particle, every field, every physical event derives its existence, its meaning, and its very reality from binary answers to yes or no questions posed by observers. The physical world is not a collection of things. It is a web of information, answers to questions that observers ask of reality. This framework resonates in unexpected ways with ideas from computer science and mathematics. The idea that reality is fundamentally informational is not unique to Wheeler. It has been proposed in various forms by a number of thinkers from different disciplines, each approaching it from a different angle, but arriving at a strikingly similar picture. Edward Fredkin, one of the pioneering figures in the development of digital computing, spent decades developing what he called digital philosophy, the view that the universe is, at its most fundamental level, a computational process, not like a computer, in the loose metaphorical sense in which the brain is sometimes said to be like a computer, but actually, literally, a computation, a process of information processing governed by rules, analogous to the rules of a computer program. In Fredkin's view, the question of what things are ultimately made of, the question that has driven physics from the ancient atomists to the modern particle physicists, has a single, irreducible answer: information. Everything else matter, energy, space, time, force, is information organized in particular ways, processed according to particular rules, representing particular states of a computational system of staggering complexity. This claim is provocative, and it is not universally accepted. Many physicists resist the computational metaphor, arguing that the universe is not literally a computer, but merely one that can, in certain respects, be described using the mathematical tools of information theory. But the informational perspective has proven extraordinarily fertile, generating new insights in fields ranging from black hole thermodynamics, where the discovery of Hawking radiation led to the realization that black holes encode information about the matter they consume in a way that connects the laws of black hole mechanics to the laws of thermodynamics to quantum error correction, where the mathematical structure underlying quantum information processing has been found to bear deep connections to the mathematical structure of spacetime itself. Gregory Bateson, the anthropologist, biologist, and cyberneticist, offered a different and perhaps more philosophically precise characterization of information, describing it as a difference that makes a difference. What Bateson meant by this is that information is not a thing, not a substance that exists somewhere in space and time in the way that matter and energy exist. Information is a relationship, a difference between states that has consequences, that causes something to happen, that makes some aspect of the world different from what it would otherwise have been. Unlike mass, which can be weighed, unlike energy, which can be measured in joules, unlike charge, which is either positive or negative or neutral information, has no specific location. It does not sit in a particular place in space. It does not flow through a particular channel. It exists, as Bateson put it, conceptually in the relationships between things, in the patterns of difference that propagate through systems and give rise to effects. This characterization of information as fundamentally relational, as existing in differences and patterns rather than in substances, has a deep resonance with the quantum mechanical picture of the physical world. In quantum mechanics, physical properties are not intrinsic features of isolated particles. They arise in the context of interactions, of measurements, of entanglements, of the relationships between systems. A particle does not have a definite position until its position is measured. It does not have a definite spin until its spin is probed in a particular direction. Its properties are not in it, waiting to be revealed by observation. They are brought into being by the act of observation, by the relationship between the particle and the measuring apparatus, between the quantum system and the observer. This is why some physicists and philosophers argue that quantum mechanics is best understood not as a theory about things and their properties, but as a theory about information and its relationships. The wave function, on this view, is not a description of an objective physical state existing independently in the world. It is a description of the information available to an observer about a system, a compact summary of what is known and what can be predicted, given a particular perspective on the world. When the wave function collapses, nothing physical happens out in the world. What happens is that the observer's information is updated. The state of knowledge shifts from a superposition of possibilities to a definite actuality. The collapse is not a physical event, but an epistemic event, a change in what is known from a particular point of view. This interpretation, known in various versions as quantum Bayesianism or cubism, has the appealing feature of dissolving the measurement problem, at least in one sense. There is no mysterious physical process causing the collapse, because the collapse is not a physical process. It is an updating of information. But it comes at a philosophical cost. It places the observer, the conscious knower, at the center of the physical picture, not as an inconvenient addition, but as a fundamental and ineliminable element of reality. Without an observer, there is no information. Without information, there is no physical world in the sense we mean when we talk about physical reality. The universe, on this view, is not made of matter that minds happen to observe. It is made of relationships between observers and systems of information, of meaning, of the irreducibly perspectival structure of conscious experience. Which brings us back to consciousness and to the extraordinary possibility that consciousness is not something that happened to the universe, but something the universe has always, at some level, been. The wave function, in the universal sense, is the most ambitious mathematical object in all of physics. The idea was proposed by Hugh Everett III in 1957 and has been developed in various ways by many physicists since. The universal wave function is a wave function that describes not just a single quantum system, but the entire universe, every particle, every field, every configuration of matter and energy throughout all of space and time. From the first instant of the Big Bang to the most distant future, it is a single mathematical object of unimaginable complexity, encoding within itself the complete quantum state of everything that is or could be. The universal wave function evolves deterministically, according to the Schrödinger equation, without any collapse. Different branches of the wave function, corresponding to different possible outcomes of every quantum event, continue to exist and evolve, never collapsing into a single actuality. This is the many worlds interpretation of quantum mechanics, and whether or not one accepts it as a literal description of reality, it illustrates in the starkest possible way the scope and ambition of the informational picture of the universe. Now consider what happens when consciousness enters this picture. If every quantum system is described by a wave function, and if the wave function represents the information encoded in the system's relationships with other systems, then consciousness, which processes and interprets information, which transforms raw sensory data into meaning, which makes choices and acts on the basis of those choices, is not simply a passive recipient of information about a pre-existing world. It is an active participant in the ongoing writing of the universal wave function. Every time you observe something, every time your conscious mind registers an event, records a fact, forms a perception, you are, in the language of quantum mechanics, causing a measurement. That measurement updates the universal wave function. It collapses certain probabilities, rules out certain possibilities, actualizes certain outcomes that were previously merely potential. Your consciousness, in observing the world, is participating in the constitution of the world's definite character, contributing, however minutely, to the ongoing process by which quantum superposition is converted into classical actuality. This is not a trivial claim, and it is not an empty one. When you think about something, when you form an intention, make a decision, direct your attention in a particular way, your brain produces specific patterns of electrochemical activity. Those patterns involve the coordinated behavior of billions of charged particles, generating electromagnetic fields that extend outward, in principle, through the entire fabric of space. Your thoughts are not private events, isolated behind the walls of your skull. They are physical events that influence the state of every particle in the universe, however infinitesimally. The universal wave function, which tracks the quantum state of everything, is sensitive to the states of everything, including the states produced by your choices and your thoughts. The wave function needs updating, in part, because quantum mechanics cannot predict the outcomes of events influenced by free will, by the choices and intentions of conscious agents. When you decide to reach for a cup of coffee rather than a glass of water, your brain generates a specific pattern of neural activity that leads to a specific pattern of muscle contractions that leads to a specific sequence of physical events in the world. None of this was determined by the initial conditions of the universe and the laws of physics operating without remainder. Your choice, whatever its ultimate metaphysical status, introduced something into the causal chain. The universal wave function, which did not anticipate your choice, must be revised to incorporate it. This implies something profound about the relationship between individual conscious beings and the larger universe they inhabit. The choices, intentions, and experiences of conscious entities are not merely epiphenomenal, not merely the froth on the surface of a deterministic physical process. They are, in the language of quantum mechanics, physically real in the most rigorous sense. They are events that update the universal wave function, that change the distribution of probabilities governing the future evolution of the cosmos. The well-being and choices of one conscious entity resonate through the interconnected web of quantum relationships, affecting, however subtly, the overall state of the universe. This picture of cosmic interconnectedness evokes something that transcends the merely scientific. It evokes a sense of awe, of participation, of responsibility. If our choices and our awareness are genuinely woven into the fabric of the universe, if the universe is, in some deep sense, made of the interactions between conscious observers and the physical world, then the universe is not the indifferent backdrop against which our lives play out. It is something we are part of, something we contribute to, something we are in continuous and intimate dialogue with, even if the language of that dialogue operates at levels too subtle and too vast for our ordinary experience to register. Before you observe something, before your consciousness engages with a physical situation and records an outcome, the wave function for that situation represents a superposition of possibilities. Every possible outcome exists in quantum superposition, weighted by its probability amplitude. When your observation occurs, the wave function updates. The possibilities that are inconsistent with what you observed are ruled out, their probabilities set to 0, and the remaining possibilities are renormalized around the outcome you actually recorded. The probability distribution then continues to evolve according to the Schrödinger equation until the next measurement is made and the process repeats. This cycle, quantum superposition, observation, wave function update, renewed superposition, is the heartbeat of the quantum universe. And consciousness, if it plays the role that some physicists and philosophers argue it plays, is the organ that drives that heartbeat. Not because consciousness is magical or outside the physical world, but because consciousness as a physical process, as a pattern of information processing, as a system that registers and responds to the states of other systems, is precisely the kind of thing that, in the quantum mechanical framework, constitutes a measurement. The universe is not observed from outside. It observes itself through the conscious beings it has given rise to. And that self-observation is, in a very real sense, part of what makes the universe definite, part of what calls the actual world from the superposition of all possible worlds into being. The measurement problem, the deep, persistent puzzle about what constitutes a measurement and what triggers the transition from quantum superposition to classical actuality, has been one of the central topics of debate in the foundations of physics for the better part of a century. Different physicists have staked out different positions, and the debate shows no sign of reaching resolution anytime soon. But what is striking is how consistently, across many different approaches and from many different angles, the question of consciousness keeps arising in connection with the question of measurement. The two problems seem to be entangled not in the loose metaphorical sense, but in something approaching the technical quantum mechanical sense. You cannot fully resolve one without at least confronting the other. All of this converges on a suggestion that an increasing number of physicists, philosophers, and interdisciplinary researchers are taking seriously that consciousness might play a fundamental role in how the universe works, not as an add-on, not as a byproduct, not as an epiphenomenon floating above the real physical story, but as a constitutive element of the story itself. The universe, on this view, is not a place where consciousness accidentally arose. It is a process in which consciousness is inherent perhaps from the very beginning, and at every level, from the quantum fields that underlie all matter to the vast networks of galaxies that constitute the large-scale structure of the cosmos. John Wheeler, as we have seen, believed that quantum mechanics implies we live in a universe made of information rather than matter. And if the universe is made of information, if information is the fundamental ontological category, then the question of what information is becomes crucially important. What, exactly, is this thing that the universe is made of? Information is increasingly recognized across multiple scientific and philosophical disciplines as a distinct physical quantity, something real, something that obeys laws, something that can be quantified and measured and manipulated, but something that is irreducibly different from matter and energy. Gregory Bateson's definition, a difference that makes a difference, captures part of its character. But information has other features that make it philosophically peculiar in ways that matter a great deal for the questions we are exploring. Unlike mass, which has a specific location in space, information does not sit somewhere. Unlike energy, which flows from place to place through defined channels, information does not have a trajectory. It is not conserved in the way that mass and energy are conserved. It exists, in Bateson's phrase, conceptually in relationships, in patterns, in the differences that propagate through systems. It is not a substance, but a structure, not a thing, but a relation. Fredkin's observation that information is the only thing for which you do not need to answer the question, what is it made of, with reference to something else, captures an important asymmetry. Every physical substance can be analyzed into its components, molecules into atoms, atoms into protons and neutrons and electrons, protons and neutrons into quarks, and so on. But information cannot be analyzed in this way. You cannot ask what a bit is made of and receive a physical answer. A bit is not made of anything. It is a logical distinction, a difference, a choice between two alternatives. It is not composed of simpler elements in the way that matter is. It is elementary in a different sense, not in the sense of being the smallest piece of a substance, but in the sense of being the most primitive and irreducible unit of a different kind of category altogether. The fundamental unit of information is the bit, a binary choice, a distinction between two states, a yes or a no. A bit can be physically instantiated in many different ways, as the presence or absence of an electrical charge, as the orientation of a magnetic domain, as the polarization of a photon. But the information itself is not the physical instantiation. The information is the logical distinction that the physical instantiation represents. Two physically very different systems can carry the same information, because the information is in the distinction, not in the physical substrate. When bits are processed by algorithms, when sequences of binary choices are combined and transformed according to rules, they collectively produce information in the richer sense, meaning conveyed through structure, patterns that represent facts about the world, descriptions that stand in for, and allow us to navigate aspects of reality. Computer programs, written in languages like C++ or Python or Java, are sequences of bits, enormous strings of zeros and ones that, when processed by the right kind of hardware, produce outputs that are rich in meaning, images, sounds, calculations, predictions, conversations. Similarly, and here is where the connection to consciousness becomes pressing, the way we arrange letters into words, words into sentences, sentences into paragraphs, paragraphs into arguments and stories and theories and works of art. All of this is the production of meaning through the organization of symbols. Language is a code. Thought is a code. Culture is a code. The world, on the informational view, is a code. And codes require, or at least strongly suggest, the existence of someone or something capable of reading them, capable of recognizing the structure and extracting the meaning. This raises a question that is both simple and staggering. What is meaning? Meaning, unlike information in the strict technical sense, does not have a clean, formal definition. It is, in a precise and important sense, tied to consciousness. Meaning is not a property of symbols in themselves. The word apple does not mean anything to a rock. The sequence of zeros and ones that encodes a photograph of a mountain does not mean anything to the computer that stores it. It is just a sequence of electrical states. Meaning arises when a conscious mind encounters a symbol and recognizes it when the symbol triggers, in the mind encountering it, a response that goes beyond mere physical registration and rises to the level of understanding, of interpretation, of connecting the symbol to the broader fabric of experience and knowledge that constitutes a mind's picture of the world. Meaning, in other words, is not in the symbol. It is in the relationship between the symbol and a consciousness capable of interpreting it. Meaning is what happens at the interface between information and awareness. It is the event that occurs when a mind reads the world. If this is right, then the informational picture of the universe carries a surprising corollary. If the universe is made of information, if the fundamental constituents of physical reality are bits, distinctions, yes or no answers to questions, then the universe is, at its most basic level, composed of the kind of stuff that requires consciousness to fully be what it is. Information, in the fullest and most meaningful sense, is not information unless there is a mind to read it. A universe of information that contains no consciousness would be, in a very precise sense, a universe of symbols with no meaning, a cosmic code that no one reads, a book written in a language that no one speaks. This does not necessarily mean that the universe requires human consciousness to exist. Perhaps any form of consciousness, any form of awareness, however primitive and alien, is sufficient to give the universe's information the character of genuine meaning rather than mere data. Perhaps the quantum fields themselves, if they have some form of experiential quality as panpsychism suggests, provide the necessary ground of meaning. Perhaps the universe is, in the deepest sense, self-interpreting a system that reads its own code through the conscious beings it generates, or through some more fundamental form of awareness that pervades it throughout. Your unique interpretation of any piece of information, a piece of music, a mathematical proof, a sunset, a conversation, is not located in the physical medium that carries the information. The meaning you take from a piece of music is not in the air molecules vibrating between the speaker and your ear. It is not in the cochlear hair cells responding to those vibrations. It is assembled, created, constructed in the extraordinary complexity of your conscious mind from the light and sound and sensation and memory and emotion and cultural context that you bring to the encounter. Every mind that encounters the same information constructs a different meaning because every mind is different, a different configuration of experience and knowledge and feeling, a different window onto the world. If we live in an information-based universe, if information is truly the fundamental stuff of which reality is made, then the universe may need to be conscious in some sense in order to hold or realize the complex mathematical meaning of the physical world it embodies. The meaning of the physical world is not in the physical world's particles. It is in the relationships between those particles, in the patterns, the structures, the organizations that those particles form, and in the minds capable of recognizing and interpreting those patterns. The universe, on this view, is not merely a collection of things. It is a text, and like all texts, it requires reading, it requires interpretation, it requires a reader. If you dream, consider what happens. You find yourself in a world a world of objects and spaces and other beings, a world with its own internal consistency, its own logic, its own textures and colors and sounds. And every single element of that world, every object, every space, every other person you encounter in the dream is made of your consciousness. There is nothing in the dream that is not an expression of your mind. The dream world is an interior universe, a universe assembled from the raw materials of your experience and memory and imagination, given form and apparent externality by the dreaming mind. In the dream, the stone is hard because your mind makes it hard. The sky is blue because your mind makes it blue. The other people in the dream speak and act because your mind, in its extraordinary creativity, generates their speech and their actions. What if the waking world is, in some analogous sense, an interior universe? What if the apparently external world, the hard stone, the blue sky, the other people we encounter, is also, in some deep sense, an expression of consciousness? Not of your individual consciousness or of human consciousness, but of a consciousness so vast and so fundamental that it constitutes the ground of reality itself? This is one of the most ancient and persistent intuitions in human philosophical and religious thought. It appears in the idealist philosophies of Berkeley and Hegel, in the non-dual traditions of Indian philosophy, in the mystical strands of every major religious tradition. It is, in its crudest form, the claim that reality is mind, that the material world is, at bottom, mental rather than physical. And it is precisely this intuition that some of the most rigorous and mathematically sophisticated thinkers in contemporary physics and philosophy are finding, to their own surprise, that they cannot entirely dismiss. The traditional view of matter, as articulated by Newton and refined by subsequent centuries of physics, is now understood to be an approximation, a useful and enormously productive simplification that captures the behavior of matter under ordinary conditions, but breaks down at the extremes, at the very small and the very fast and the very dense. At the quantum level, matter is not what Newton thought it was. It is not a collection of tiny solid balls moving through empty space. It is excitations of quantum fields, patterns of activity in an underlying medium that is everywhere and continuous and deeply, irreducibly non-classical. The concept of matter as a solid, tangible, mind-independent substance, the intuitive picture that most of us carry through our daily lives, is, at the level of fundamental physics, an illusion. Or rather, it is an emergent approximation, a way of describing the behavior of quantum fields in the regime, relevant to our sensory experience, but not a description of what those fields actually are. Part of the revolution in our understanding of matter comes from the realization that matter, as classically conceived, is no longer considered the foundation of life or of anything else. Instead, matter is part of a continuum, part of an ongoing evolutionary process rooted in the quantum field, in which particles and forces and structures emerge, persist for a time, and dissolve back into the underlying field. The distinction between living and non-living matter, between organic and inorganic chemistry, between biology and physics. These distinctions are real and important at the levels at which we encounter them, but they do not reflect a fundamental discontinuity in the fabric of reality. At the quantum level, everything is part of the same continuous field, governed by the same underlying laws, participating in the same endless process of emergence and dissolution. Since everything in the universe ultimately arises from quantum mechanical events, since every particle, every force, every structure, every process has its roots in the quantum level, it has been proposed by physicists and philosophers working at the intersection of these disciplines that the universe is governed by a greater consciousness field, not a consciousness in the human sense, not a personality, not an intelligence in the deliberative, goal-directed sense that we associate with human minds, but something more fundamental and more pervasive, a field of awareness, a ground of experience that underlies and permeates all physical reality in the way that quantum fields underlie and permeate all matter. This proposal is not obviously different in its structural features from panpsychism as described earlier, but it adds something, the suggestion that this cosmic consciousness field is not merely a passive background, but an active organizing principle, that it plays a role in the evolution of the universe, in the emergence of structure and complexity, in the development of life and intelligence, and the capacity for ever deeper self-knowledge. The universe, on this view, is not merely conscious. It is self-consciously evolving, moving through processes that operate on cosmic timescales toward ever more elaborate and ever more aware expressions of its own fundamental nature. Understanding consciousness may require, as some researchers in this area argue, not merely a neuroscientific or psychological analysis of the kind of consciousness that humans and animals experience, but an analytical study of higher states of consciousness, altered states, meditative states, mystical states, in which the boundaries of the ordinary individual self become permeable, in which the distinction between the observer and the observed softens, and in which something like a direct acquaintance with the underlying field of awareness becomes available to experience. These higher states have been reported across cultures and throughout history in the accounts of mystics and meditators and contemplatives from every religious and philosophical tradition. They have been dismissed by mainstream science as hallucinations, as pathological disturbances of normal brain function, as symptoms of oxygen deprivation or neurochemical imbalance. But a growing number of researchers are arguing that this dismissal is premature, that these states may be genuine windows into aspects of reality that ordinary waking consciousness does not access, and that a complete science of mind will need to take them seriously. Through studies of the quantum mind and the exploration of quantum realities at the biological and neurological level, living beings are no longer viewed merely as chemical generators, metabolic machines that convert food into movement and thought. They are increasingly seen as participants in an energy network, a collective field that connects them to each other and to the larger fabric of the universe. This field moves us, on this view, beyond our ordinary sense of being separate, isolated selves, beyond the experience of the individual mind enclosed in the individual skull, walled off from the rest of reality by skin and bone into something larger, a unified structure, a shared field of consciousness in which the boundaries between self and world, between individual and cosmos, are less absolute than our ordinary experience suggests. This is not mysticism dressed up in scientific language, or rather, it may be mysticism, but it may also be science. The boundary between the two is less clear than it once appeared. The quantum field does not respect the boundaries of the individual body. Entanglement connects particles across arbitrary distances instantaneously without any signal traveling through space. The universal wave function encompasses everything. The measurement problem implicates consciousness in the constitution of physical reality. The structural similarity between the neural network and the cosmic web suggests that the universe organizes itself according to principles that we associate with mind. The informational picture of reality suggests that meaning which requires consciousness to exist is fundamental to the fabric of the cosmos. Each of these threads, taken individually, might be dismissed or explained away. Taken together, they weave a pattern that is harder to ignore a pattern, suggesting that the relationship between mind and universe is not one of contained and container, of observer and observed, of accident and backdrop, but something far more intimate, far more mutual, far more strange. The vastness that this picture opens up the sense that our individual minds are not isolated accidents in a mindless cosmos, but local expressions of a cosmic mind, nodes in a network of awareness that encompasses everything from the quantum vacuum to the observable horizon of the universe, allows for something extraordinary. It allows us to direct our minds and our hearts and our attention toward the great mystery and wonder of universal existence. It invites us to experience, not merely intellectually, but in some more direct and immediate way, the profound reality and majesty of the cosmic domains of life. Before us lies the mystery of life and consciousness, a mystery so vast and so deep that every answer we find opens up new questions. Every understanding we reach reveals new horizons of incomprehension. And before us lies, perhaps more excitingly still, the possibility of exploring the universe within each of us, the inner cosmos that each conscious being constitutes, the dimension of experience and awareness and meaning that no telescope can observe and no particle accelerator can probe, but that is, if anything, more immediately and undeniably real than anything the instruments of external science have ever discovered. The human journey into this territory, the territory of the information age, yes, but more fundamentally, the territory of consciousness and its relationship to the cosmos, is, in many respects, just beginning. The tools we have available, the mathematics of quantum mechanics, the network science of complex systems, the neuroscience of the brain, the philosophy of mind, and the extraordinary instrument of conscious attention itself, are more powerful and more sophisticated than anything available to previous generations. What we choose to do with them, the questions we choose to ask, the directions we choose to explore, will shape not only our understanding of the universe, but perhaps, if the participatory picture is correct, the universe itself. There is a moment, familiar to anyone who has ever stood beneath a truly dark sky, far from the glow of cities, when the sheer scale of the universe stops being an abstract fact and becomes a felt reality. The light reaching your eyes has travelled for millions, in some cases billions of years, to arrive at this specific moment of contact with your specific consciousness. The photons striking your retinas were emitted by stars that may no longer exist, by galaxies whose current state is entirely unknown to you and to anyone, by processes that unfolded before the Earth itself had formed. You are not looking at the universe from outside. You are a part of it, a fold in its fabric, looking back at itself through the particular aperture of your awareness. And in that moment, the question that seems abstract and academic in daylight, the question of whether the universe is, in some sense, alive, in some sense, aware, in some sense, more than the sum of its indifferent mechanical parts, becomes charged with a kind of urgency that no textbook formulation can fully capture. That question whether the universe is alive, whether it is conscious, whether it is something more than a vast and impersonal machine grinding through deterministic processes in a darkness, relieved only by the accidental flicker of biological awareness, is the question that animates everything we have been exploring. And it is a question that, as we have seen, reaches far deeper than the visual similarity between the cosmic web and the neural network, as striking as that similarity is. It reaches into the foundations of quantum mechanics, into the philosophy of mind, into the mathematics of information theory, into the history of human thought about the nature of reality, and into the lived experience of consciousness itself. Let us take stock of where we have arrived, and then press further into territory that is even less charted, even more uncertain, even more alive with the possibility of genuine discovery. We have seen that the universe organizes itself at the largest observable scales into a structure that bears a deep and mathematically precise resemblance to the neural architecture of the human brain. We have seen that quantum mechanics, the most successful and rigorously tested scientific theory in history, places the conscious observer in a special and irreducible relationship with the physical world, one that the theory's own formalism cannot fully explain away. We have seen that the most fundamental picture of physical reality available to contemporary science is an informational picture, a picture in which the universe is made not of stuff, but of distinctions, not of substance, but of relationships, not of things, but of the patterns of difference that propagate through the quantum fields underlying all matter. And we have seen that information, in the fullest sense information, as meaning, rather than merely as data requires consciousness to be what it is. These convergences do not constitute a proof. They do not establish, beyond reasonable doubt, that the universe is conscious. Science is not yet in a position to make that claim, and intellectual honesty requires acknowledging that clearly. What these convergences constitute, rather, is a deeply suggestive body of evidence that the materialist picture, the picture of a universe made entirely of mindless matter, in which consciousness is a local accident, a late arrival, a temporary and inconsequential flickering in the vast darkness of a fundamentally inert cosmos, may be radically incomplete. Perhaps not merely incomplete in the way that Newtonian mechanics is incomplete, approximately true over a limited domain, superseded by a more comprehensive framework that reduces to it in appropriate limits, but incomplete in a more fundamental way, at the level of basic ontological categories, at the level of what we take the universe to ultimately be made of. The history of science is, in part, a history of the revision of fundamental ontological categories. The ancient atomists thought the world was made of indivisible, solid particles, moving through empty void. Newton thought it was made of massive point particles interacting through instantaneous action at a distance. Maxwell and Faraday replaced the point particle picture with a field picture, continuous fields permeating all of space, carrying energy and information, making the concept of instantaneous action at a distance obsolete. Einstein deepened the field picture by showing that space and time themselves are dynamical fields, curved by the presence of matter and energy, constituting the fabric within which all physical processes unfold. Quantum mechanics then revealed that even the fields of classical physics are approximations to something stranger, quantum fields, whose excitations behave neither as particles nor as waves in the classical sense, but as something irreducibly quantum that has no classical analogue. At each step in this progression, the ontological picture changed not merely in its details, but in its fundamental character. The world looks different, is different, in the most philosophically serious sense at each level of the analysis. And at each step, phenomena that seemed mysterious or paradoxical at the previous level of understanding are dissolved or recontextualized by the new framework. Action at a distance was mysterious in the particle picture and was dissolved by the field picture. Wave-particle duality was mysterious in the classical field picture and was recontextualized, if not fully dissolved, by quantum mechanics. The hard problem of consciousness may be, in the same way, a puzzle that signals the need for a new and deeper level of ontological understanding, a level at which the relationship between mind and matter is not a problem to be solved, but a starting point to be explored. Consider what it would mean, concretely, if consciousness were indeed a fundamental feature of the quantum fields that constitute all of physical reality. It would not mean that the electron is thinking about its next interaction. It would not mean that the photon has preferences or intentions. What it might mean in the most carefully formulated versions of panpsychist or cosmopsychist theory is that there is, associated with every physical system, some form of interior dimension, some primitive, unstructured, pre-reflective quality of being what it is, not experience in the rich, articulate, self-aware sense that characterizes human consciousness, not anything that we would recognize from the inside as experience at all, but some faint, irreducible interiority that constitutes the raw material from which richer forms of experience are built as physical systems become more complex and more integrated. On this picture, the difference between a rock and a brain is not the difference between a system that has absolutely no interior dimension and one that has an interior dimension. It is the difference between a system with an interior dimension of essentially zero complexity and integration, a mere dim flicker of the most primitive possible experiential quality, and a system with an interior dimension, staggering complexity, integration, and richness, capable of self-reference and memory and imagination and love, and the perception of beauty and the formulation of questions about the nature of the universe. The rock and the brain are not categorically different in whether they have an interior. They are different in degree in the richness, the complexity, the depth of the interior they have. And the universe, the vast, ancient, complex, self-organizing, information processing system that is the universe, might have an interior that dwarfs the human brain's interior in the same way that the brain's interior dwarfs the rock's, by many orders of magnitude, in dimensions that we have barely begun to develop the conceptual vocabulary to describe. This is not a comfortable picture for those accustomed to the clean, objective, mind-independent universe of classical physics. It is a picture that requires revising some of our deepest intuitions about the nature of reality. But then, every major advance in fundamental physics has required exactly that, a willingness to revise intuitions that seemed obviously correct, to follow the mathematics and the evidence into territory that our unaided common sense would never have anticipated. The double-slit experiment, in which a single particle fired at a screen with two slits produces an interference pattern that proves it went through both slits simultaneously, violates every intuition we have about how objects move through space. Yet it is an empirical fact verified in thousands of experiments with electrons, photons, atoms, and even molecules. Quantum entanglement, in which two particles can be correlated in such a way that measuring the state of one instantaneously determines the state of the other, regardless of the distance separating them, violates every intuition we have about locality and separability. Yet it too is an empirical fact, verified in increasingly sophisticated experiments over the past several decades. The universe does not care about our intuitions. It behaves as it behaves. And our job is to develop the conceptual and mathematical frameworks adequate to describe its actual behavior, however strange and counterintuitive that behavior turns out to be. If the behavior of the universe at the quantum level, the measurement problem, the role of the observer, the reality of entanglement and non-locality points toward a picture in which consciousness is not peripheral but central, not accidental but fundamental, then the appropriate response is not to retreat into comfortable materialism for the sake of simplicity or familiarity. The appropriate response is to follow the evidence, however strange the territory it leads into. But let us be precise about what following the evidence actually looks like in this domain, because this is where the genuine scientific challenge lies. The challenge is not merely to develop philosophical frameworks that are consistent with the available evidence. Philosophy is good at that. The challenge is to develop empirical predictions, things that would be different in measurable and observable ways if consciousness is fundamental rather than epiphenomenal. Without empirical predictions, we have philosophy and metaphysics, which are valuable and important, but we do not yet have science in the narrow, testable sense. Several research programs are attempting to meet this challenge, with varying degrees of rigor and credibility. Integrated Information Theory, or IIT, developed by neuroscientist and psychiatrist Giulio Tononi, proposes a precise mathematical measure of consciousness, a quantity called phi, which measures the degree of integrated information in a system. Phi quantifies how much information is generated by the system as a whole, above and beyond the information generated by its parts independently. A system with high phi, like the human brain, with its massively parallel and densely interconnected processing, has a high degree of integrated information and, on the IIT framework, a correspondingly high degree of consciousness. A system with low phi, like a simple computer or a random collection of particles, has little or no consciousness. Crucially, IIT makes quantitative predictions that are, at least in principle, empirically testable. It predicts, for instance, that the cerebellum, which contains far more neurons than the cerebral cortex, but has a much more modular, less integrated architecture, should contribute less to consciousness than the cortex, despite its greater neuron count. This prediction is consistent with clinical observations of patients with cerebellar damage, who typically do not lose consciousness despite suffering significant motor impairments. IIT also predicts that certain artificial information processing systems, even very powerful ones, capable of extraordinary feats of computation, will have very low consciousness if their architecture is not sufficiently integrated, because integration, not raw computational power, is what generates consciousness according to the theory. IIT is not without its critics, and some of its claims remain highly controversial, but it represents a serious and technically rigorous attempt to give panpsychism, or at least a version of the view, that consciousness is tied to physical structure in a precise and quantifiable way, the kind of empirical grounding that would make it a scientific rather than merely a philosophical proposition. If IIT is correct, consciousness is not a mysterious extra ingredient added to certain physical systems from outside. It is an intrinsic feature of systems with sufficient integrated complexity, a feature that can be measured, compared, and predicted from the physical structure of the system. The orchestrated objective reduction hypothesis, developed by physicist Roger Penrose and anesthesiologist Stuart Hameroff, takes a different approach. Penrose argues, in his books The Emperor's New Mind and Shadows of the Mind, that human consciousness involves a type of computation that cannot be replicated by any classical algorithm, a type of computation that requires, at its foundation, a quantum mechanical process that is not simply the standard unitary evolution of the Schrödinger equation. He proposes that this quantum process involves a form of objective wave function, collapse a genuine physical process, not merely an epistemic updating that occurs within the microtubules inside neurons, tiny cylindrical protein structures that form part of the cellular skeleton. Hameroff, who had been studying the role of microtubules in cellular function for decades, proposed that these structures are precisely the kind of quantum mechanical substrate that Penrose's theory requires. The Orch-Orr hypothesis, orchestrated objective reduction, is the result of their collaboration. The proposal that consciousness arises from quantum computations in neuronal microtubules, computations that are orchestrated by synaptic inputs and other neural processes, and that terminate in objective quantum state reductions that are connected through quantum gravity to the fundamental geometry of spacetime. Orch-Orr is perhaps the most radical and most contested of the serious scientific proposals about the physical basis of consciousness. Its critics argue that the brain is too warm and too wet to sustain the quantum coherence required for the microtubular quantum computations. The theory posits that decoherence would destroy any quantum state in the brain far too quickly for it to play any functional role. Its defenders argue that living systems may have evolved mechanisms for protecting quantum coherence against decoherence, and point to the discovery of quantum coherence in photosynthesis, in the navigation systems of birds, and in other biological processes, as evidence that quantum effects in warm, wet biological environments are not as impossible as the critics assume. The debate is ongoing, and the empirical evidence is not yet decisive in either direction. But the existence of the debate, the fact that serious physicists and neuroscientists are willing to stake their professional reputations on propositions as radical as Orch-Orr, is itself a significant indicator of how dramatically the intellectual landscape has shifted in recent decades. A generation ago, such proposals would have been dismissed out of hand as fringe science. Today, while they remain controversial, they are taken seriously enough to be published in peer-reviewed journals and debated at major scientific conferences. Beyond IIT and Orchor, there are other research programs that, while not explicitly framing themselves as theories of fundamental consciousness, are contributing to the broader picture in important ways. The neuroscience of the default mode network, the set of brain regions that is active when the mind is at rest, not engaged in any specific external task, apparently engaged in a kind of self-referential processing, has revealed that the brain's resting state is not a passive or quiet state, but an intensely active one, generating the continuous background narrative of selfhood and experience that constitutes what we ordinarily call the mind. The default mode network may be a key neural correlate of the sense of self, the sense of being a particular individual with a particular history and a particular perspective on the world, and understanding its dynamics may be crucial to understanding how the brain generates the kind of integrated, self-aware, temporally extended consciousness that characterizes human experience. Research into altered states of consciousness, including the states produced by meditation, by psychedelic compounds, and by certain clinical conditions, is revealing that the ordinary waking state of human consciousness, far from being the natural baseline or the full extent of what consciousness can be, is one point in a vast landscape of possible states, most of which remain almost entirely unexplored. Meditators trained in deep contemplative practices report states in which the sense of self as a bounded, isolated individual dissolves, in which the experience of separation between the observer and the observed, between the self and the world, softens or disappears entirely, replaced by a sense of open, undivided awareness that encompasses everything without being located anywhere in particular. These states are not well understood neuroscientifically, but they are consistent with the theoretical picture in which ordinary individual consciousness is a construction, a particularly stable and useful pattern of neural activity, rather than the fundamental ground of awareness, which may be something far more expansive and far less bounded. Psychedelic research, which experienced a renaissance in the early decades of the 21st century after decades of regulatory suppression, has produced findings that are deeply relevant to these questions. Compounds like psilocybin, DMT, and LSD produce dramatic alterations in consciousness that, in many cases, bear a striking resemblance to the mystical states reported by contemplatives across cultures and throughout history, states characterized by a sense of unity with the cosmos, by the dissolution of the ego boundary, by an overwhelming sense of meaning and significance, and by what many subjects describe as a direct perception of the underlying nature of reality. Whether these perceptions are veridical, whether they reveal something genuinely true about the structure of the universe, or whether they are simply the brain-generating experiences in the absence of its normal constraints, is a question that cannot yet be answered definitively. But the consistency of these reports across subjects, cultures, and historical periods, and the apparent therapeutic value of the insights they generate, suggests that they are pointing towards something real, even if we do not yet have the conceptual tools to fully articulate what that something is. The study of near-death experiences provides another window into these questions. People who have been clinically dead, whose hearts have stopped, and whose brains have shown no measurable electrical activity, and who have subsequently been resuscitated, frequently report experiences during the interval of apparent death that are vivid, coherent, meaningful, and profoundly transformative. They report experiences of tunnels of light, of encountering deceased relatives, of a life review in which the emotional impact of their actions on others is directly felt, and most relevant for our purposes, of a profound sense of connection with a larger whole, a sense of the self dissolving into a vast field of consciousness that is experienced as fundamental and real in a way that ordinary waking life is not. These experiences are deeply puzzling for any theory that locates consciousness entirely within the physical activity of the brain. If consciousness is simply a product of brain activity, it should not be possible to have coherent, meaningful experiences when the brain is showing no measurable activity. The standard explanations residual brain activity below the detection threshold, hallucinations generated during the process of resuscitation, the subjective distortion of time under extreme physiological stress are not obviously adequate to account for all the features of these experiences, and the debate about their interpretation is ongoing. For our purposes, what matters is not whether near-death experiences provide evidence for the survival of consciousness after death. That is a question too large and too contested to be resolved here. What matters is that these experiences, like the experiences reported by meditators and by users of psychedelic compounds, consistently point toward a picture of consciousness as something larger, more fundamental, and more continuous with the universe than the ordinary bounded self we inhabit in everyday life. They suggest not prove, but suggest that the individual mind is not the only form that consciousness takes, and perhaps not the most fundamental form. They suggest that consciousness may extend beyond the boundaries of individual organisms, beyond the boundaries of individual brains, into something that more closely resembles the pervasive, field-like, cosmically distributed awareness that the philosophical traditions of panpsychism and cosmopsychism posit. Now, having explored all of these threads, the structural similarity of brain and cosmos, the measurement problem of quantum mechanics, the informational picture of reality, the philosophy of panpsychism, the neuroscience of consciousness, the evidence from altered states and extreme experiences, let us step back and ask what kind of universe we might be living in if all of these threads are pointing in the same direction. We might be living in a universe that is not merely the setting for consciousness, but the source of it. A universe in which the capacity for experience is not a late arriving accident, but a fundamental, irreducible feature present from the first instant, woven into the quantum fields that constitute the fabric of reality, elaborating itself through the long history of cosmic evolution into ever richer and more complex forms. A universe in which the emergence of life, and of intelligent life, and of the kind of self-reflective, wonder-experiencing, question-asking consciousness that characterizes human beings, is not an improbable fluke, but the expression of something deep in the nature of the cosmos, a tendency, perhaps, toward increasing complexity and integration and self-awareness that is as fundamental as the tendency toward entropy or the pull of gravity. A universe, in other words, that is in some meaningful sense alive, not alive in the narrow biological sense, not alive in the sense of breathing or metabolizing or reproducing, but alive in the sense of being intrinsically aware, intrinsically experiential, intrinsically oriented toward its own deepening self-knowledge. A universe that does not merely contain minds, but that is, at some level and in some sense, a mind so vast and so alien that no human category or concept can capture it fully, but a mind nonetheless. Real in its awareness, real in its capacity for something like experience, real in its irreducible interiority. If this picture is even partially correct, its implications for how we understand ourselves are profound. We are not, on this view, accidents brief, inconsequential flickerings of awareness in the vast darkness of a mindless cosmos, destined to be extinguished without trace or significance. We are the universe knowing itself. We are the local, particular, richly elaborated expressions of a cosmic capacity for awareness that has been developing for nearly 14 billion years, and that will continue to develop in forms we cannot yet imagine for billions of years to come. Every experience we have, every moment of perception, of thought, of feeling, of connection with another conscious being is a moment in which the universe is deepening its self-knowledge, adding to the extraordinary accumulation of awareness and meaning and understanding that constitutes, perhaps, the most fundamental project of the cosmos. This is not a trivial reframing. It changes the meaning of what it is to be a conscious being. It changes the moral weight we assign to experience, to all experience, not merely to human experience, but to the experience of every conscious being capable of feeling, of suffering, of joy, of the simple baseline quality of being aware. If consciousness is not an accident, but a fundamental feature of the universe, then the universe has, in giving rise to conscious beings, given rise to something of irreducible value, something that the universe itself, in some sense, requires for its own completion. It also changes the relationship between science and what has traditionally been called spirituality. The deepest insights of the world's contemplative traditions, the sense of unity with the cosmos, the dissolution of the separate self, the experience of consciousness as vast and foundational rather than narrow and localized, have always been difficult to accommodate within the materialist picture of the universe. They have been dismissed as illusion, as neurological artifact, as wishful thinking, as the brain generating comforting fictions in the face of its own mortality. But if the scientific picture is moving toward a view in which consciousness is fundamental, in which the universe is made of information, and information requires awareness to be meaningful, in which the observer is not outside reality looking in, but inside reality, constituting it, then perhaps the contemplatives were not deluded. Perhaps they were, in their own conceptual vocabulary and through their own distinctive methods, arriving at truths about the nature of reality that science is only now, by a completely different route, beginning to approach. This convergence between the insights of ancient contemplative wisdom and the findings of contemporary fundamental physics is one of the most remarkable and least discussed phenomena in the intellectual life of our time. It does not mean that science and spirituality are the same thing, or that there are no important differences between them in their methods, their standards of evidence, their characteristic questions and concerns. There are profound differences, and they matter. But it does mean that the sharp opposition between a scientific worldview and a spiritually inflected one, the assumption that to take science seriously is necessarily to reject any picture of the universe as meaningful, experiential, or aware, may be less secure than it seemed. The physicist Carlo Rovelli, in his Meditations on Quantum Gravity and the Nature of Time, writes about the universe as a web of relationships, a network of events and interactions in which nothing has intrinsic, observer-independent properties, and in which the apparent solidity and permanence of the physical world is an emergent feature of the relational structure rather than a fundamental given. This relational picture of physics shares deep structural features with the Buddhist philosophical tradition's conception of dependent origination, the idea that nothing exists independently, that all phenomena arise in dependence on other phenomena, that the apparently solid world of separate objects is a construction built from underlying processes of relation and interaction. The convergence is striking enough that several contemporary physicists and philosophers, including Rovelli himself, have explored it explicitly. Similarly, the physicist David Bohm's concept of the implicate order, his proposal that beneath the explicit, manifest order of the physical world there lies a deeper, enfolded order in which everything is connected with everything else, and from which the apparent separateness of distinct objects unfolds, as an approximation shares deep structural resonances with various non-dual philosophical traditions that describe reality as a seamless whole that only appears divided into separate things from the perspective of ordinary consciousness. Bohm was explicit about these connections, engaging directly with Eastern philosophical traditions throughout his career and arguing that the mechanistic worldview of classical physics had introduced a fragmentation into human thought that was as philosophically distorting as it was scientifically limiting. These convergences do not constitute proof of anything. They are suggestive rather than demonstrative. but they contribute to the growing sense that the picture of the universe that is emerging from the frontiers of contemporary physics and philosophy is not the cold, mindless, purely mechanical picture that dominated scientific culture in the 19th and 20th centuries. It is something richer, stranger, more interior, more alive, a picture that leaves room, perhaps, for the intuitions that human beings have expressed across cultures and throughout history about the meaningfulness of existence, the reality of consciousness, the interconnectedness of all things, and the possibility that the universe is not merely the stage upon which awareness accidentally appeared, but the source from which awareness continually springs. Let us return to where we began, to Franco Vazza and Alberto Feletti, sharing a drink and an extraordinary conversation, and to the image that their subsequent collaboration produced, a side-by-side comparison of a section of the human cerebral cortex, imaged at microscopic resolution, and a computer simulation of the cosmic web, rendered at cosmological scale. To the untrained eye, the two images are almost indistinguishable. The same filaments, the same nodes, the same voids, the same hierarchical clustering, the same quality of intricate, organic, purposeful seeming architecture. To the trained eye, as Vazza and Feletti demonstrated, the similarity persists under rigorous quantitative analysis. The mathematical signatures of the two structures align in ways that cannot easily be dismissed as coincidence. What are we to make of this? Vazza himself is cautious, and his caution is scientifically appropriate. Just because two things look alike does not mean they are the same thing, or that they function in the same way, or that the resemblance carries the metaphysical weight that some people want to assign to it. The cosmic web and the neural network arose through completely different physical processes, operate through completely different mechanisms, and exist at scales that differ by more than 27 orders of magnitude. The resemblance may reflect nothing more than the operation of universal mathematical principles governing the behavior of complex, self-organizing networks, principles that apply regardless of the specific physical substrate, and that therefore produce similar structures in many different systems. But even this more conservative interpretation is remarkable in its own right. Universal mathematical principles, principles that apply across 27 orders of magnitude of scale, across completely different physical mechanisms, across systems as different as a biological brain, and the large-scale structure of the cosmos are not trivial. They are hints at something deep in the mathematical fabric of reality. They suggest that there is a sense in which the universe is organized, structured by mathematical regularities that operate at every scale and that give rise, wherever the relevant conditions are met, to certain preferred architectural forms. And the preferred architectural form that produces both the human brain and the cosmic web is, of all the possible forms that complex networks might take, precisely the form that we associate with the capacity for information processing, for the integration of signals from many different sources, for the kind of coherent, coordinated activity that we associate with mind. Whether this is a coincidence or a clue, whether it reflects the accidental operation of scale-free mathematical laws, or the expression of something more fundamental about the relationship between structure and experience, is a question that science is not yet in a position to answer definitively. But it is a question worth taking seriously. It is a question worth pursuing with every tool available, with the mathematics of network science and quantum field theory, with the empirical methods of neuroscience and observational cosmology, with the conceptual resources of philosophy of mind and philosophy of physics, and with the direct investigation of consciousness itself that contemplative traditions have refined over millennia. We stand at an extraordinary juncture in the history of human inquiry. The instruments we have built are capable of imaging the structure of the universe from the scale of the quantum vacuum to the scale of the observable horizon. The mathematical frameworks we have developed are capable of describing the behavior of physical systems with a precision that would have seemed miraculous to scientists of any previous era. The philosophy of mind has achieved a level of rigor and sophistication in its engagement with the hard problem of consciousness that makes the question, however difficult, tractable in ways it was not before. And the willingness, still tentative and contested but growing, to take seriously the possibility that consciousness is not peripheral but fundamental, not accidental but essential to the nature of reality, represents a genuine shift in the intellectual atmosphere of our time. What lies ahead is not merely the accumulation of more data or the refinement of existing models. What lies ahead, if the hints we have been exploring are pointing in the right direction, is something more profound, a revision of the basic picture of what the universe is and what our place in it is, comparable in depth and scope to the Copernican revolution, to the Darwinian revolution, to the quantum revolution. A revision that would situate consciousness not at the margins of the physical picture, but at its center, not as the fortunate byproduct of a universe that might just as well have produced none, but as the universe's own most intimate nature, knowing itself through the extraordinary variety of forms that the long process of cosmic evolution has given rise to. Perhaps consciousness did not simply emerge or flicker into existence at some point in the history of the universe. Perhaps it has always been present, inherent in the quantum fields from which everything arises, present in the first instant of the Big Bang, elaborating itself through 14 billion years of cosmic evolution, achieving in the human brain and the human mind one of its most complex and self-aware expressions, and destined to continue developing, deepening, and diversifying into forms that we, from our present vantage point, cannot begin to anticipate. The journey toward understanding reality and consciousness is not a journey with a predetermined destination. It is an ever-evolving quest, a continuous exploration that challenges every assumption, expands every horizon, and opens onto the limitless possibilities that lie in the vast expanse of the unknown. Every answer reveals new questions. Every understanding deepens the mystery. Every step forward into the unknown changes the landscape of what is known, and reveals that the territory still unmapped is larger, more intricate, and more astonishing than anything we had previously imagined. We are the universe's way of wondering about itself. We are the instrument through which the cosmos becomes curious about its own nature, through which the extraordinary fact of existence achieves, in the narrow aperture of a conscious mind confronting the night sky, something like self-awareness. That is not a small thing. That is, perhaps, the most significant fact about the universe that we have yet discovered, more significant than the age of the cosmos, more significant than the scale of the cosmic web, more significant than the quantum nature of matter or the curvature of space-time. The universe is not only extraordinarily vast and extraordinarily ancient and extraordinarily complex, it is in us, and perhaps through us, and perhaps far beyond us, extraordinarily aware. What we do with that awareness, how carefully we attend to it, how deeply we investigate it, how honestly we follow the evidence wherever it leads, how courageously we revise our most cherished assumptions in the light of what we find, will determine the depth and the quality of the understanding we are able to achieve. The universe has, through 4 billion years of biological evolution and several 100,000 years of human cultural evolution, produced minds capable of asking whether the universe is alive and conscious. Whether it has, in doing so, produced minds capable of answering that question, or whether the question is too large for any mind to answer from the inside, remains to be seen. But the asking of the question, with all the rigor and all the wonder and all the intellectual courage it demands, is itself one of the most extraordinary things that has ever happened in the long, strange, magnificent history of the cosmos. The greatest tool available to us in this investigation is not the telescope or the particle accelerator or the mathematical apparatus of quantum field theory, impressive and essential as all of these are. The greatest tool is the consciousness that uses all of those instruments, the awareness that frames the questions, interprets the data, constructs the theories, and ultimately must confront, in the privacy of its own experience, the deepest questions about what it is and what the universe it inhabits ultimately is. This tool is not something we acquired or built or discovered. It is our birthright, the one thing that every conscious being possesses simply by virtue of being conscious, the one thing that is present in every experience regardless of its content, the ground on which every investigation is conducted and from which no investigation can step outside. It is called consciousness. And if the ideas we have been exploring are even partially correct, it may be the most fundamental, the most pervasive, and the most astonishing feature of a universe that is, from the smallest quantum event to the largest cosmic structure, from the first instant of time to the farthest horizon of the future alive.